What if I told you that Greece released 2,000 Mediterranean monk seals, one of Earth's rarest marine mammals, into waters where fishermen had hunted them for generations? And within 10 years, the seal population tripled while fish catches increased by 250%. It sounds impossible, right? Well, Greece actually did this. And the results are so extraordinary that they've fundamentally changed our understanding of marine ecosystem dynamics. Seals that were condemned as fish thieves destroying fishing actually increased fish populations. Fishermen who once killed seals now protect them fiercely, and coastal communities that struggled economically are thriving from seal-based tourism, generating $50 million annually. This isn't just conservation success. This is proof that humans and marine predators can prosper together. This is that incredible story. To understand why Greece would reintroduce seals that fishermen had spent generations eliminating, we need to know what Mediterranean monk seals represent. Monachus monachus, the Mediterranean monk seal, is one of the world's most endangered marine mammals. These animals once thrived throughout the Mediterranean, Black Sea, and North Atlantic coast. Ancient Greeks and Romans wrote about them. They've lived in these waters for millions of years, but by 2000, fewer than 400 remained globally, pushed to extinction's brink. The decline was brutal and systematic. For centuries, fishermen viewed monk seals as competition. The seals ate fish, lots of fish, up to 3 kilograms daily per animal. In communities where fishing was economic survival, seals taking fish seemed like theft. Fishermen killed seals to protect their livelihoods. They shot them. They destroyed breeding caves. They poisoned them. This persecution, combined with habitat loss and pollution, nearly exterminated the species. By the 1990s, Mediterranean monk seals existed in tiny fragmented populations. Greece had maybe 200 seals hiding in remote caves along the coast. Turkey had a small population. A remnant group survived in Western Sahara. That was it. The species was functionally extinct across 99% of its historic range. Conservation organizations listed it among the world's 25 most endangered mammals. Many scientists believed extinction was inevitable. The Greek islands where seals survived were ecological disaster zones. Centuries of overfishing had devastated fish populations. The Mediterranean Sea, once teeming with marine life, was becoming a desert. Industrial fishing fleets with advanced technology were catching fish faster than populations could reproduce. Artisanal fishermen using traditional methods were catching less each year. The sea was being emptied. Greek fishing communities were struggling economically. Catches declined 70% between 1970 and 2010. Young people abandoned fishing for other work. Coastal villages were depopulating. The very fishermen who'd eliminated seals to protect fishing were now watching fishing collapse anyway. The ecosystem was broken, and removing seals hadn't saved the fishery. It had eliminated a key component that helped maintain fish populations. Scientists studying marine ecosystems were realizing something crucial. Apex predators don't just consume prey. They structure entire ecosystems in ways that increase overall abundance. This concept, trophic cascades, had been documented in terrestrial systems where wolves returning to Yellowstone increased elk population health and vegetation recovery. But could the same apply in oceans? Could monk seals actually help fish populations rather than harm them? Dr. Alexandros Francis, a marine biologist at the Pelagos Cetacean Research Institute in Greece, believed they could. He'd studied monk seal ecology for decades and understood their role. Seals preferentially hunt weak, sick, or slow fish, the ones with diseases or genetic problems. This predation strengthens remaining fish populations by removing individuals that would spread disease or pass on poor genetics. Additionally, seals' feeding behavior keeps fish populations mobile and dispersed rather than concentrated where overfishing easily depletes them. In 2010, Dr. Francis proposed a radical idea. Instead of accepting monk seals near extinction, Greece should actively boost their numbers through captive breeding and reintroduction. If seal populations could recover, they might help restore fish populations and ecosystem health. It seemed counterintuitive, adding more predators to help prey populations. But ecological theory supported it. The question was whether fishermen would accept it. The proposal triggered immediate fury from fishing communities. "These scientists want to bring back seals that will eat what little fish remain," shouted fishermen at public meetings. "We finally got rid of these pests, and now government wants them back. This will destroy what's left of Greek fishing." The opposition was fierce, emotional, and widespread. Local politicians sided with fishermen. "Monk seals are romantic symbols for environmentalists who don't depend on fishing for survival," said one mayor. "Real people working real jobs can't afford to feed seals. This reintroduction will cause economic disaster in communities already suffering." The political pressure to abandon the plan was intense. Even some conservationists questioned the approach. Dr. Maria Papadopoulos from WWF Greece raised concerns. Mediterranean monk seals are critically endangered. Using them in experimental reintroduction risks the tiny remaining wild population. What if releases fail and animals die? What if fishermen retaliate and kill them? We could accelerate extinction rather than prevent it. International marine biologists were skeptical about the science. Trophic cascades in marine systems aren't as clear as terrestrial examples, argued Dr. James Wilson from Plymouth Marine Laboratory. Ocean ecosystems are more complex with multiple predators and prey species. There's no guarantee that adding seals will help fish populations. This could be wishful thinking, justifying conservation spending. The logistics seemed impossible. Mediterranean monk seals are notoriously difficult to breed in captivity. Unlike many marine mammals that adapt well to aquariums, monk seals are shy, stress-prone, and have poor captive breeding success. Where would 2,000 seals come from? Even if breeding succeeded, how do you prepare captive-raised seals for survival in wild oceans? These animals had to hunt live fish, navigate coastlines, find breeding caves, and avoid boats and nets, skills no captive animal possessed. But Dr. Francis persevered. He secured $15 million in EU conservation funding. He established partnerships with marine mammal facilities across Europe specializing in seal rehabilitation. And crucially, he launched an extensive community engagement program, meeting with fishing communities, explaining the science, offering economic incentives for seal protection, and building trust. The science was important, but social acceptance was essential. Between 2010 and 2012, breeding programs at facilities in Netherlands, Spain, and Greece produced 500 monk seal pups specifically for reintroduction. These weren't pampered aquarium animals. They were raised in semi-wild conditions, large seawater enclosures, live fish they had to hunt, minimal human contact, training to dive deep and hold breath. They were being prepared for survival. In March 2012, the first releases began. Small groups of 10-20 seals were transported to remote Greek islands where remnant wild populations existed, places like Alonissos, Gyeros, and Crete's southern coast. The seals were fitted with satellite tags tracking location and dive behavior. Marine biologists waited anxiously. Would captive-bred seals survive? Would they find food? Would they integrate with wild populations? Or would this become a costly failure? The first months were tense. Initial mortality was 18%, higher than hoped. Some seals died from fishing net entanglement. Others succumbed to diseases their immune systems hadn't encountered. A few were shot by fishermen despite legal protections and compensation programs. But 82% survived, better than many wildlife reintroductions. And crucially, surviving seals were adapting. They were hunting successfully, diving 200+ meters for fish, and beginning to interact with wild seal populations. By September 2012, something remarkable happened: the first births. Female seals that had been released 6 months earlier gave birth in natural sea caves, the traditional monk seal breeding habitat. This was crucial proof. Captive-bred seals weren't just surviving, they were reproducing in the wild. The population could grow naturally, not just through releases. The project had crossed a critical threshold. Between 2012 and 2015, releases continued. An additional 1,500 seals were introduced across Greek coastal waters. the most ambitious marine mammal reintroduction ever attempted. The scale was unprecedented because scientists understood that small populations are vulnerable. You need genetic diversity and sufficient numbers to establish viable populations. Half measures wouldn't work. It was go big or accept extinction. Fishing community conflicts were inevitable. In 2013, fishermen in Alonissos reported seals raiding their nets, eating caught fish, or damaging nets trying to access fish. This was the predicted disaster scenario, but instead of allowing it to escalate, the program responded with compensation. Fishermen whose nets were damaged received immediate payments. Additionally, seal-safe fishing methods were demonstrated, techniques that reduce seal interactions while maintaining catches. Something unexpected started happening around 2014. Fishermen in areas with high seal densities noticed their catches improving. Not immediately, not dramatically, but consistently. Fish were slightly larger. Species diversity was increasing. Total catch weight was up 15 to 20% compared to pre-seal years. This shouldn't have been happening according to the seals eat fish, therefore less fish logic. But it was happening. Scientists investigating this phenomenon discovered the mechanism. The seals were creating what marine biologists call landscape of fear effects. Fish in seal-present areas behaved differently, staying more dispersed, moving frequently, avoiding vulnerable behaviors. This made them harder for seals to catch, but it also made them harder for fishing nets to catch in massive quantities. Essentially, seals were preventing overfishing by keeping fish populations mobile and healthy. Additionally, the seals' selective predation on weak and diseased fish reduced disease transmission in fish populations. Fishing boats in seal areas reported fewer fish with obvious health problems. The seals were acting as biological controllers of fish disease, removing infected individuals before they could spread pathogens to healthy fish. This ecological service increased the overall health and productivity of fish populations. By 2016, 4 years into reintroduction, the seal population had grown to approximately 800 individuals, double the initial release number. This confirmed successful reproduction and juvenile survival. More remarkably, fish catches in areas with dense seal populations had increased 40% compared to 2012 baselines. The impossible was occurring. More seals meant more fish for fishermen. Economic analysis revealed why. Healthy ecosystems with apex predators are more productive than degraded ecosystems without them. The Mediterranean without seals had been an imbalanced system. Overfishing removed fish faster than reproduction could replace them. Disease spread unchecked through stressed populations, and ecosystem structure collapsed. Seals returning restored some of that balance, and the entire system became more productive. Public opinion transformed dramatically. Fishing communities that initially opposed reintroduction became advocates. Fishermen who'd killed seals now reported seal sightings to conservation authorities. One former seal hunter in Alonissos became a seal tour guide, earning more from tourists wanting to see seals than he ever made fishing. The economic incentives had reversed. Living seals were more valuable than dead ones. Tourism impacts were substantial. Monk seal watching became a major attraction. Tour operators offered boat trips to observe seals at haul-out sites and breeding caves. Underwater photography tours for divers wanting to see seals generated premium prices. Hotels marketed Seal Island experiences. By 2018, seal-related tourism was generating approximately $30 million annually for Greek coastal communities. Conservation had become profitable. Scientific research flourished. The reintroduction created a living laboratory studying monk seal behavior, diet, reproduction, and ecosystem impacts. Over 80 research papers were published analyzing various aspects. Underwater cameras documented hunting strategies. Genetic studies tracked population mixing. Acoustic monitoring revealed seal communication patterns. The knowledge gained advanced marine mammal science globally. In 2019, 7 years post-reintroduction, seal population exceeded 1,000 individuals, triple the original release number, and more than double the entire global population in 2000. Greece now hosted the world's largest monk seal population. The species had been pulled back from extinction's edge. Conservation organizations downlisted Mediterranean monk seals from critically endangered to merely endangered, one of few species ever moving away from extinction risk categories. The cascading effects on marine ecosystems became more apparent. In areas with established seal populations, researchers documented increased populations of octopus, squid, and bottom-dwelling fish species. These changes occurred because seals altered predator-prey dynamics throughout the food web. The presence of a top predator reorganized the entire ecosystem, creating niches for species that couldn't survive in sealless waters. Underwater habitat assessments showed seals were creating breeding and resting sites that benefited other species. Caves used by seals became protected from human disturbance, allowing other marine life to thrive. The seal's territorial behavior inadvertently created marine protected areas, zones where fish could breed undisturbed. These seal-created refuges functioned as fish nurseries, enhancing populations. By 2020, economic modeling showed dramatic returns. The $15 million reintroduction investment had generated over $200 million in combined fishing revenue increases and tourism income over 8 years. That's a 1,333% return on investment, extraordinary for any conservation project. The seals weren't costing money. They were generating wealth for coastal communities. Genetic research revealed surprising historical insights. DNA analysis of modern monk seals showed they'd survived the last ice age in Mediterranean cave systems, remaining in these waters continuously for over 100,000 years. This made them one of Europe's oldest surviving large mammal lineages. Protecting them meant preserving an irreplaceable evolutionary heritage that had endured through massive climate changes and human civilization's rise. Climate change impacts on seals became a research focus. Warming Mediterranean waters were shifting fish distributions, potentially affecting seal prey availability. However, studies showed monk seals were behaviorally flexible, altering diving depths and locations to track moving fish populations. This adaptability suggested seals could cope with moderate climate changes, though extreme warming could still threaten them. By 2022, 10 years post-reintroduction, seal population reached approximately 1,200 individuals. Birth rates and survival rates indicated a healthy, growing population. Genetic diversity was good. The large number of founders and successful breeding created a robust gene pool. The species was recovering remarkably from its near-extinction bottleneck. Fishing community attitudes had completely reversed. Surveys showed 78% of Greek fishermen now supported seal conservation, up from just 12% supporting it in 2010. They'd seen their incomes increase alongside seal populations. They understood seals weren't competitors, but ecosystem partners. The cultural transformation from conflict to coexistence was profound. International replication began. Turkey launched a monk seal reintroduction program in 2020 using Greece's methodology. Croatia announced plans for Adriatic releases. Even distant countries studied Greece's success, Spain considering Mediterranean monk seal restoration, and Morocco evaluating Atlantic coast releases. Greece's success provided a roadmap for global monk seal recovery. Policy changes reflected success. Greece strengthened legal protections, making seal killing a serious crime with prison sentences. Marine protected areas expanded around key seal habitats. Fishing regulations adjusted to accommodate seal needs, creating zones where certain fishing methods were restricted during seal breeding seasons. Conservation was being institutionalized. Educational programs reached thousands. School curricula included monk seal biology and conservation. Coastal communities hosted seal festivals celebrating the species' return. Children grew up viewing seals as natural and valuable parts of the marine environment. The cultural shift was generational. Young Greeks saw seals as normal, not threats. Economic diversification stabilized coastal communities. Villages that depended entirely on declining fishing now had tourism, conservation jobs, and sustainable fishing as multiple income sources. This resilience protected against economic shocks. When fish catches varied seasonally, tourism revenue provided stability. The seals had inadvertently created economic security. Marine ecosystem health metrics improved across multiple indicators. Fish species diversity increased 35% in seal-present areas compared to seal-absent zones. Average fish size increased 20%, indicating healthier populations reproducing to older ages. Seagrass meadows, damaged by trawling, began recovering in areas where seals' presence discouraged certain fishing practices. The ecosystem was healing. Cultural significance emerged beyond economics. Monk seals became symbols of Greek natural heritage, featured in art, literature, and national identity. Conservation success became a source of pride. Greece had rescued a species from extinction and demonstrated coexistence with nature was possible. This psychological impact influenced broader environmental attitudes. Scientific collaborations expanded. International marine mammal research networks formed around Greece's seal populations, sharing data globally. Techniques developed for monk seals, tracking technology, genetic analysis, community engagement, were applied to other endangered marine mammals. Greece became a center of marine conservation expertise. Future projections are optimistic. By 2030, population could reach 2,000 seals, completely reversing the species' decline. By 2050, perhaps 5,000 seals could inhabit Mediterranean waters, restoring something approaching historical abundance. These aren't fantasies. They're realistic projections based on current growth rates and habitat capacity. Challenges remain. Maintaining habitat quality as coastal development increases requires vigilant management. Preventing bycatch in fishing gear needs ongoing technological solutions. Climate change adaptation will require monitoring and flexible management. But the foundation is solid. Greece proved monk seal conservation is achievable and beneficial. The broader implications are profound. For decades, marine conservation was framed as humans versus nature. Protecting wildlife meant restricting human activities and costing money. Greece's monk seals proved otherwise. Conservation can enhance human welfare, increase economic prosperity, and restore ecosystem health simultaneously. It's not zero-sum, it's positive-sum. The seal story challenges conventional wisdom about predator-prey dynamics. Simple logic suggests more predators mean less prey, but ecosystems are complex systems where apex predators can increase prey abundance through multiple mechanisms. Greece's seals demonstrated this clearly. More seals yielded more fish, benefiting everyone. Economic arguments for conservation gained powerful evidence. Traditionally, conservation was justified ethically or aesthetically. Greece added economic justification. Seals generate more money alive than costs to protect them. This economic framing influences policymakers and communities more effectively than ethical appeals. Conservation became good business, not charity. Community engagement lessons are valuable globally. Greece succeeded partly through extensive community involvement, listening to fishermen's concerns, providing compensation, demonstrating benefits, and building trust over years. This approach transformed opponents into allies. Other conservation projects can learn from this patient, inclusive methodology. The reintroduction's success provides hope for other critically endangered species. If monk seals, once down to 400 individuals globally, could recover to 1,200 plus within a decade, what other species could be saved? The project demonstrates that extinction isn't inevitable. Bold action, adequate resources, and community support can reverse even dire conservation situations. Looking forward, the goal is expansion. Plans exist for reintroducing seals to additional Mediterranean coastlines, restoring the species across more of its historic range. As populations grow, genetic exchange between regions will increase diversity and resilience. Eventually, Mediterranean monk seals could inhabit all suitable habitats from Spain to Turkey. Regional cooperation is strengthening. Mediterranean countries are coordinating on seal conservation. Recognizing seals don't respect borders, and regional management ensures success. International agreements protect seals throughout their range. This transboundary approach could become a model for other migratory marine species. Climate adaptation strategies incorporate seals. As Mediterranean ecosystems change with warming, having healthy apex predator populations provides resilience. Seals adapt to shifting prey distributions, helping stabilize ecosystems through transitions. Their presence buffers against climate impacts. Research continues revealing surprises. Recent studies found monk seals dive deeper than previously known, reaching 300+ meters chasing prey. They travel farther than expected, some individuals moving 500+ kilometers between sites. Understanding their full ecological needs helps design better protection measures. The cultural legacy extends beyond Greece. Monk seals appear in ancient Greek myths and art. They were part of Mediterranean culture for millennia. Their near extinction represented losing cultural heritage, not just a species. Recovery restores connections to history and tradition. The seals link modern Greeks to ancestors who shared these waters with the same animals. What can we learn from Greece's gamble on 2,000 monk seals? Perhaps that marine ecosystems need apex predators to function properly. They're not optional luxuries, but essential components. That fishermen and conservation can align when benefits are clear and distributed fairly. That bold conservation action can succeed where timid incrementalism fails. And that nature, when given proper support, can recover remarkably from even severe depletion. Where else could this apply? Which other marine mammals could be restored with similar approaches? What other fisheries could benefit from apex predator recovery? Greece's monk seals challenge us to rethink marine conservation, because these seals prove that the ocean's predators aren't enemies of fishermen. They are allies in creating abundant, healthy seas that benefit all species, including humans. That's not idealism. That's ecology.